Hi students, in this video I'll be going through the 4E5 and additional mathematics mid-year exam 2019 paper 2 question 6. Okay, so this is a question on tangents and normals. Okay, so let's read the question. Okay, so the question goes, the gradient of the curve y equals to a over x squared plus b over x at the point -1, -5 is -6, where a and b are constant. So find the value of a and b. Right, so whenever you see a question whereby there are two unknowns, A and B, to be solved, okay, the first thing that should come to mind would be to solve simultaneous equations. Okay, because whenever you have two unknowns, you should always try to form two equations, and then if you solve them simultaneously, you should be able to find the values of A and B. Right, so let's see how we can get the first equation. So they say that the gradient of the curve of this particular curve at the point -1, -5. Okay, so the fact that they mentioned this, okay, we can infer that the curve will actually pass through this point, -1, -5. So this will actually allow us to get our first equation, because now we can say that when x is -1, y will be -5. All right, so that will allow us to get the first equation. So let's write that down. So when x equals to -1, y will be equals to -5. Right, so let's sub the y and x inside. So -5 equals to a over -1 square plus b over -1. So you have a minus b, right? So I'm going to write this on the left side. So a minus b equals to -5. So this is going to be our equation 1. Okay, so where would the equation 2 come from? Okay, so you look at this piece of info. Okay, they say that the gradient of the curve at the point -1, -5 is -6. Okay, I don't know how the curve looks like, so I'm just going to randomly draw something like this. Okay, because I know the gradient is negative. So at this point, okay, -1, -5. Okay, the gradient of the tangent at this point. Okay, so this is a red line. Okay, not good. Okay, let me change the color of my marker, maybe to green. Okay, then let's try to draw the tangent again. Okay, nice. Okay, let me try to draw it this way. Oh, okay, so it's 5. Okay, so the tangent, okay, so let's say this is the tangent at the point -1, -5. What they are saying is that the gradient of this tangent will be -6. Right, so the gradient of tangent is -6. Okay, so we also know that dy dx is actually the gradient function. Okay, so what this means, another expression would be dy dx equals to -6 when x equals to -1. Why x equals to -1? Because it's a tangent at the point whereby x is equals to -1. Alright, so this will actually allow us to form the second equation. Okay, so what we're going to do now is we're going to dy dx this particular equation over here, and then after that we're going to sub x equals to -1 inside the dy dx, and then equate it to -6. Right? Okay, so let's do it. So let's prepare the function for differentiation first. So we have this. Okay, so we'll write it in this form, plus b x to the power of -1. Okay, so let's differentiate this. Okay, dy over dx equals to, okay, power comes down, then -1 to the power. Okay, same thing, -1 comes down, so get -bx to the power of -2. Right, so in other words, dy dx will be -2a over x cubed minus b over x squared. Okay, so this will be your dy dx. Okay, so as mentioned, when x equals to -1, dy dx will be -6. So let's form the second equation. So when x equals to -1, dy over dx equals to -6. Okay, so let's sub -1 inside the x over here. So -2a over -1 cubed minus b over -1 square will allow dy dx to be -6. Okay, so over here we will get 2a. Okay, -1 cubed is -1, then negative and negative will become positive. Negative 1 square will be 1, so minus b equals to minus 6. So this will be equation 2. Okay, so our equation 1 is over here. Our equation 2 is over here. Okay, both have minus b, so I guess we can use the elimination method, right? So we're going to use equation 2 minus equation 1. Okay, so left-hand side minus left-hand side. So left-hand side of equation 2 minus left-hand side of equation 1 will be equals to right-hand side of equation 2 minus right-hand side of equation 1. Okay, so be careful, minus, minus, right? Okay, so from here, we will be able to get a equals to negative 1. Okay, then we sub a equals to negative 1 into equation 1. Okay, so we'll get negative 1 minus b equals to negative 5. So b will be equals to 4. Right, so this will be the answer for a and b, right? Okay, so once we get the values of a and b, okay, then actually we know the full equation of the curve, right? It's going to be negative 1 over x squared plus 4 over x. And we also know the dy dx. Okay, the dy dx value here has a and b, right? So we can actually write it as dy dx equals to, okay, a is negative 1. If you put negative 1 inside, negative 2 times the negative outside, it just becomes 2 over x cubed. Then minus b, so b is 4, right? So minus 4 over x squared. So this is the dy dx and the y, right? Okay, let's look at part 2 of the question. Okay, find the equation of the normal to the curve at the point where x equals to 1. Okay, so now there's another part of the curve. I also don't know what the shape of the part looks like, so I just draw something like this. Okay, so at this point where the x coordinate is 1, where x is 1, right? Okay, they want us to find the equation of the normal. Okay, so let me use a color pen. Okay, so the tangent will be over here. Okay, so this will be the tangent. Okay, normal will be perpendicular to the tangent, so normal will be over here. Okay, so they want us to find the equation of this normal. Equation of this normal. Okay, so in order to find the equation of a line, you need to know two things. Firstly, you need to know the coordinates of one point that the line passes through. Over here, we know that the x coordinate is 1 already. So let's try to find the y coordinate. Okay, this is the same curve as in part 1. So to find the y coordinate is very easy. You just sub the x coordinate inside the equation of the curve, you will be able to find the y coordinate. So the equation of the curve is over here, right? Okay, so let's sub x equals to 1 inside. Okay, so when x equals to 1, okay, you're going to sub inside this one. So y will be negative 1 over 1 square plus 4 over 1. Okay, so here we'll get negative 1 plus 4, you'll get 3, right? So we know that the normal, okay, which we want to find the equation, passes through the point 1, 3. Okay, so this one is 1, 3, right? So we know the point. Okay, so the other thing that we need to know in order to find the equation of a line would be to know its gradient. So what we want to find is the gradient of the normal over here. Okay, the gradient of the normal. Okay, but in order to find the gradient of the normal, we need to find the gradient of the tangent first. Okay, we need to find gradient of the tangent. Okay, why? Because gradient of tangent is perpendicular. The tangent is perpendicular to the normal, right? So that means the product of their gradients will give us negative 1. Okay, so how do we find the gradient of the tangent? Okay, all what we need to do is sub x equals to 1. Okay, because the tangent passes through at this point, right? Where x equals to 1, sub x equal to 1 inside the dy dx, and that will give us the gradient of the tangent at x equals to 1, right? So dy dx is over here. So let's write down again dy dx equals to 2 over x cubed minus 4 over x squared. Okay, so when x equals to 1, dy over dx equals to 2 over 1 cubed minus 4 over 1 squared. Okay, so get 2 minus 4, get negative 2. Okay, so the gradient of this tangent is equal to negative 2. Right, so once we know the gradient of the tangent, then it's easy to find the gradient of the normal. Okay, so gradient of tangent times gradient of normal equals to -1 because they are perpendicular. Okay, so the next thing is gradient of tangent, we know is a -2 already, right? So -2 times gradient of normal equals to -1. So that means the gradient of the normal would be actually half, right? So the gradient of this one is actually equals to half. Okay, so now that we know the gradient of the normal, we know it passes through 1, 3, then we can find the equation of the normal very easily. Okay, so the equation of a straight line can be found in this form: y minus y1 equals to gradient x minus x1, where x1 and y1 are the coordinates of one point that the line passes through. So in this case, it will be 1, 3. And m is the gradient of the line that we want to find. In this case, it will be half. Okay, so y minus 3 equals to half x minus 1. Okay, so just simplify this and you'll be able to get the answer already. Okay, so y will be half x. Okay, negative half plus 3 will get 2.5, so 5/2. Right? Okay, so this is the answer over here. Okay, so not too difficult. So just a quick recap. If you have two unknowns, okay, in this case A and B, then you should be thinking about forming simultaneous equations and then solving the two simultaneous equations, right? Okay. Then once you found the values of A and B, then you know the equation of the curve fully, you know dy dx fully, then we can make use of it to solve part 2 of the question. Okay, so for part 2 of the question, to get equation of any line, okay, in this case the normal, you will need to know the coordinates of one point that the line passes through and the gradient of that line. Okay, so to find the gradient of normal, we find the gradient of the tangent first, and then gradient of tangent times gradient of normal will be -1. So that will allow us to find the gradient of the normal. Right, so this is how you do the question like this.